Thank you very much for being here. Hopefully in next 40-45 minutes, I will show something interesting to you that you can learn and build based on that. I would like to start today with several questions, like how many of you deploy their services to Kubernetes clusters, and how many of you usually able to, like, imagine that you have a new service and you need a new namespace and everything in cluster. Like, how many of you are able to get it less than 1 day? Like, let's say you get to infrastructure team and they do everything in 1 day. So yeah, now there was many hands, but I now see 2 or maximum 3. That's great. It seems like we have a topic to talk about. That's exactly the topic. So quickly about me, I'm engineering lead at DataRobot. I'm leading a common infrastructure team, which platform engineering team. The solutions I'm going to show you, some of them is exactly how we implement, how we do things at DataRobot. Some of them are things that we don't necessarily use in that way. I will talk about them. But this talk is about more like, to give some ideas to you about how platform teams actually can make you to get the Kubernetes clusters in less than day, hours, probably, hopefully in a minute or so. So let me tell you a story, like very small story. Imagine you are a developer, you have a new shiny service, you tested it, you have the repository, Helm chart, everything ready to deploy to Kubernetes. And yeah, now it's time to get things done and ship it to production. And let's assume in this story, our service is basic Python Flask service, which I'm going to show you, which connects to a database, does something, like let's say it's a Postgre database in AWS RDS. Then you need IAM role to access that service, and then you will have secret, and then you need a simple ALB, like load balancer, that people from outside can access to your service. Like, very simple story. So our talk from now on will be based on this. Like, obviously, you can change the application from Python to another language also, so it's not Python specific. And you can change anything in this picture. Like, if it's not RDS something else, that's also totally fine. But to make things easier and to show you a real demo, let's continue from this story. So what happens? You need a new namespace, and most probably you go create a Jira ticket or whatever, and wait for infrastructure team, security team, based on your organization, to provide a single namespace in cluster, probably with all the namespace limits, exceptions, controls, and so on. So a few moments later, which based on my experience usually takes days, even weeks or so, which actually was one of the problems we solved at DataRobot. So the few moments later pass, then you want RDS and the secrets in the cluster to connect to RDS. So another Jira ticket or something like this, and again few moments pass, hopefully those are moments. Then like this continues like this, and at the end we have something like this. You request namespace with Jira or something else, you get the namespace. Then you request RDS, then someone provisions the RDS, then you get it. Then you request a secret, okay, how I'm gonna connect to this RDS, what's the host name and so on. Then you get it. Then you need network policy. If your Kubernetes cluster has a network policy controls in place, then you need network policy. Then you ask for it again, then someone provisions the network policy, you can get access and so on. Sometimes security teams, even in this picture, depending on organization structure, there might be more or less players. This is just a story. Then hopefully at the end, you do the security review with security team. They verify that you are not doing something bad with your Helm charts and so on. Then you finally deploy. But I believe this is not the way, and at DataRobot, we believe this is not the way. The solutions I'm going to show you, it's built by a great team I'm leading. They are not very fancy stuff, but that's our approach. So again, it's not on my own implementations, it's our team's implementation. So I'm going to go to the details now. So in that picture, let's think backwards. Let's think that, okay, at the end, what we need, RDS, secrets, and everything, a namespace, and some controls in place, And when we think backwards, how we can make this self-service? How we can make sure that developer is able to create RDS, create namespace, put all the controls in place, create the network policies, and we automatically do some verifications. Like we don't really need someone from security to manually check if we are not doing something bad with your Helm charts, or how do we make sure that there's no real infrastructure team need to go either do Terraform apply or in the AWS Web Console create the RDS, and then populate the secrets into the Kubernetes cluster. So let's think backwards and see how we can solve this. So basically what we need, namespace, RDS, load balancer, secrets, and some control mechanisms in place. Like you can do this yes, or you can't do this no. So the goal is self-service platform. Self-service platform in this case means that you abstract away all these complexities from developers. They don't have to know about how you are creating these resources, what control mechanisms you have in place, like which tools are using, and they don't really have to learn all these tools. Like there are many tools that helping us to abstract away details, like external secrets, which we are gonna look. Like you can put a secret in AWS Secret Manager, and external secrets can synchronize that secret into your cluster as a secret. And whenever there's an automatic rotation or something in that secret, in a matter of seconds, which you configure it's seconds, minutes, or hours, your secret is populated to your cluster. Then there's controllers like Crossplane, there's Terraform controllers, there's AWS Kubernetes controllers that you can create your RDS instance simple by just doing kubectl apply YAML file. So our goal is this. Our goal is to abstract away all these complexities and don't expect developers will learn what external secrets is, what all these tools are. They will just get some templates from platform engineering teams, and they know how to use these templates and get into clusters. So now I'm going to break it down like how we achieve this, what we can do to achieve this. So I have a cluster running. There's some namespaces, and some of these tools are installed, like Crossplane, external secrets, then Kyverno, and yeah, Kubernetes-related namespace. And I'm going to show you. I have a very small application. It's not something fancy. It's a Python Flask application. What it does, it tries to connect to a Postgres and just, checks the database version, queries it, and it queries hello world, like select version and hello PyCon. Nothing specific. This is just verify that we are going to able to connect to RDS. And yeah, I have Docker file for it. I pushed it to the image registry. What's next? I have a Helm chart for it. So I have deployment file, I have ingress, secrets, and so on. This secret is everything commented. I will show you why. So this is just a Helm chart to deploy it, and there's some values expected, like ingress configuration and the repository. I'm gonna just pull it from my repository in Docker Hub, and some secrets. We will get back to this. Actually, this is not a very good way of attaching secrets to your deployment, but we will be back to this. So we are expecting database host, database name, port, password, and user. So yeah, I will try to deploy this. Now, should I go and create a ticket and wait here? Probably no, right? Let's see what we as a platform engineering do for this use case. We have a Helm chart named Onboarding. I will show the structure of it to you. Let's focus here. So this is a basic Helm chart, like every developer at our company is able to use. This Helm chart has like Kyverno exceptions and policy exceptions. It allows you to set limits for your namespace. It allows you to create the namespace itself, set quotas, and configure airbag. What this looks like, let me quickly show you. So let's say I want to onboard myself to this Kubernetes cluster. What I need to do, I have to specify some minimum values, and they are all controlled in this Helm chart again. Like there's templates, you can see Kyverno limits, namespaces, and so on. And yeah, each team, like in this case, since I'm trying to deploy my application, I need a simple values file, simple onboarding values file that I define my tenant name, because since this is a multi-tenant Kubernetes cluster, we are attaching some tenant name to every service. Then Kyverno false exceptions if needed, and namespace. Like I will start with namespace. No Kyverno exceptions, nothing. I just define my tenant name and my namespace. So I want to create this namespace. What I do helm install. Let me actually find the full command. It will be easier. No, it doesn't work. Sorry. Great. Yeah, something like this. So what I do, I install this chart. I just name it my PyCon onboarding. This is Helm chart. Helm chart always requires a namespace. In this case, I'm going to use default namespace. That's not the point. And I'm going to specify my YAML file, which should create the namespace for me. And, you know, okay, give me a second. Okay, I should be in this folder. Yeah. So, yeah, it doesn't exist. It's installing it now. So, based on our values file, it should create this namespace for me, right? Let's have a look. When I did the kubectl get namespace initially, there wasn't any application namespace. When I'm doing it again, so I have my application namespace here already. So imagine that this is actually what we do. This Helm chart is part of every CI/CD pipeline, and before deployment, people create the namespace, codes, and everything. And if they make any change to their codes and exceptions or anything, it's applied. Then the next stage of the CI/CD pipeline, the application is deployed. Okay, I have the namespace. What's next? What I need? There was an RDS, right? I need an RDS. So I'm going to demo this with Crossplane. We actually don't use Crossplane at our company, but this is going to show you an idea, like the self-service database provisioning idea. So I'm not going to go to the details of Crossplane, what it is or how does it work, but I will just simply show you the YAML file, how it works, and what we are going to do. That should be enough for this use case. So I have Crossplane deployed in the cluster, configured, everything is in place. Because you are a developer, you don't really need to think about that, right? This is actually example what I want to show you. As a platform engineer, I configured this. You don't know how it works, and you shouldn't even know. You just know there's something in the cluster. And as a platform engineer, I give you a template. I give you a YAML file template like this, and I say, just configure this based on your needs, and at the moment you do kubectl apply, you will get an RDS. What this template looks like, you obviously specify a name and identifier, which is the RDS name in AWS console. You select how much storage you need. You select the RDS engine. In this case, this is Postgre. It could be MySQL or anything RDS supports. The version, the instance type for it, then the database name. I will get back to this. So do you want it to be publicly accessible or no? The region you want to deploy it, the username. This is actually reference to a Crossplane related configuration. You don't really need to know about it, but just go to Crossplane documentation. You will learn about it if you want to. What is this? Manage master user password. RDS has a functionality that when you create RDS, you can tell RDS to synchronize secrets, to automatically create secrets like database username and password, and get it to AWS Secret Manager. And AWS will do all this for you. It will rotate it, it will configure everything, there won't be any issue. So we are setting this true, and we are telling RDS, please configure my username and password in AWS Secret Manager. So yeah, mine is simple. I'm going to use this. What I'm going to do, kubectl apply, it's RDS YAML file. Yeah, it says it's created. Let's see what's happening. I'm going to connect to my account. You see there was nothing. Refreshing. You see, my app.db instance 001 is being created by simple kubectl apply command. Now, while this is being created, I am also going to secret manager. So we see this is popped up. What's this? This is again username and password created by AWS service. So there will be when it's ready, when it's fully provisioned, there will be a username and password. Now I need some additional stuff, which is the database name and connection endpoint. So I'm creating this one. Like I created this before. It's just manual creation, and I'm gonna update this value because I will have a new endpoint. But DB name is my app. Where is it coming from? It's coming from here. It's RDS functionality. Nothing strange. So now, when the secret is ready, it will be in AWS Secret Manager. And I also have this RDS connection, which shows me the host, DB name, and everything in Secret Manager. So how do I get this to the cluster? Now, again, create ticket for infrastructure team, or do some kubectl apply. Let's try kubectl apply way. We have another tool named external secrets. Like as I mentioned at the beginning, can populate these secrets to the cluster. So we go to our other template provided by our platform engineering team to us, and it's named external secret. So let's have a look. It's external secret resource. It requires namespace. I already set the namespace we created today here. And it's looking for DB user, DB password in specific key in Secret Manager. This key is the name of this AWS Secret Manager secret. So I'm going to copy this, paste it here. Oops, sorry. Yeah, I have it here. I have it here. So it will be looking for username inside this, and it will populate it as a DB user in secret Kubernetes secret name DB credentials. Then the password will be there the same way. Here I'm creating the second one for my DB host, DB name and port, which secret will be named DB connection. It will be looking for RDS connection in Secret Manager, which is this one. And it will populate everything to the cluster, and yeah, it will be named DB connection. So DB connection and DB credentials. Let's go back to our Helm chart values. You see, I have specified them here. So you can change the name here and adjust here appropriately. It's just platform engineering team gives you templates and you play with it in a way you want. You name things in a way you want. So let's see. I assume our secret's already populated. Let me see. First RDS. Let's go to RDS. So far so good. Seems like demo gods are with me today. I'm happy about this. Yeah, we have endpoint. Just copying this one. I'm going to Secret Manager. So this, as I mentioned, this is for my test before conference. This is not going to work. I destroyed that already. So I updated. This is the new DB host. So I have the DB host here, and I think it's safe to retrieve this because I'm going to delete this anyways. So yeah, RDS also populated the admin user and password for me. So we had the namespace, right? kubectl get secrets and app01 ns. This was the namespace we had, right? There's nothing. No resources found in this namespace. I check my YAML file once more. I have this one properly set up. I have this one properly set up. So what I do now, I go to my secrets. I apply all the resources here. So it says created, all good. Now, what does it mean? Some magic should happen, and I should get my secrets in this namespace. Yes, they're there. Even we can go here and try to retrieve values. This may be a bit smaller, sorry for that. But yeah, this is my namespace. You see, I have DB host, DB name, DB port here. I have DB credentials here. Everything ready. So I have RDS, I have secrets populated. Now I am ready to deploy my application. So there's one more thing I have to show you before deployment. We also talked about the requirement of AWS load balancer controller, right? So the AWS load balancer can be provisioned by AWS load balancer controller. The only thing it requires you to set some annotations in your ingress. As long as you set the ingress class as ALB and specify it in the internet facing, there's another controller working in cluster which you as a developer don't even think about, is ALB ingress controller, which automatically provisions a real load balancer in cluster for you. So I'm gonna to check my load balancers first to see if I have anything or not. And there's nothing. Okay, so this will provision it for me. And then I check all the secrets here, everything is fine. So helm upgrade install my app icon. Let me find the command I prepared. That will be easy. Helm upgrade install. Yeah. So I'm just gonna name it my app, the helm name, and I'm specifying the namespace I'm deploying it. Yeah. So it's deployed. I'm going to list of pods. I see my services coming. Actually, I can also do this. kubectl get pods and my namespace. So I see my services running. Let's see and I see a load balancer is being provisioned for me automatically by Kubernetes. And while the load balancer is being provisioned, I will try to local port forwarding and see if my application is able to connect to the database, to the RDS. Yes, it is. It executed select version. This is the select version result. And it executed hello PyCon. So the secrets are automatically in Kubernetes. They're the correct ones. RDS provisioned, and my application is able to connect to the database. Let's wait for a couple of seconds. This will be ready, and we should be able to reach to that with this DNS name. We can take this demo to further. We can install tool like external DNS in our cluster, then connect it to our Route 53 zone. Then it will even populate DNS zone name for us, and create an A record for this load balancer name. So far, so good. But as I mentioned, we did something bad here. Attaching secrets in this way to deployments to pods is not very good practice. It's against best practice. And as a platform engineer, I want you to not to do this. I want you to mount secrets. And I want to ensure that I am somehow automatically checking this, instead of each time requiring you to create a Jira ticket and ask me or security team to review your Helm chart, right? Now I have a tool called Kyverno. Kyverno is a policy engine. There's an alternative open policy agent. You can also try that one. So this is pure platform stuff. This is something I do in my site as a platform engineer. I set a cluster policy. I name it secret not from environment variables. This is an actually open source policy I took from EKS best practices website. And this policy controls that any pod resource is not attaching anything from environment variable, any secret. This is the important part. For now, the validation failure is audit. When it's audit, your application will still work, but it will just create a policy report, and you will see some errors in kubectl events that you are not doing something right. But I can set this as an enforce, and you won't be able to deploy that application, and you will get the error. So let's look at the audit mode, because more or less we will see the same policy report, and that's what we need. So as a platform engineer, I go to, when I am creating my cluster, I am adding policies like this, okay? I'm creating policy like this. Okay. Get for. So it will take a while, then we should see some policy reports. But while this is happening, there's already one event. I don't know if you can read it or not. It says you are not doing something right. So since it's audit mode, you just see this as an event. But if I convert to enforce mode, you won't be able to deploy this application till you fix it or till you create an exception. The exception obviously always has to be approved by security team or depending on your organization structure, but you can fix this. So let me see if the policy reports are available. Yes. So in your namespace, you always see policy reports, and we see like my deployment, my replicas at my pod has one failure. So let's have a look into this. kubectl get. This is something as a platform engineer, I give you a template like, and a small guide like how you can make this, how you can analyze this. So you should be able to see what's failing in self-service manner and fix it. Yeah, let me specify the namespace. There should be a way to describe this. No. Yeah, dash o YAML. Yeah, that's great. Yeah, that's what I need. Thank you. Yeah. So here, see some passed, but some failed. What it says, secrets must be mounted as volumes, not as environment. Since this is audit mode, your application still works, but this gives you error message. What we do in our environment at DataRobot, we set this as an audit mode in development clusters, and we set enforce mode in production clusters. So you as a developer, when you onboard yourself in self-service way to development cluster, you see this, you have a chance to fix all this, verify your policy reports, then go to production, and you're done. Let's say this is a specific thing that, you know, security approved, and you want to get an exception for this. You remember the onboarding file? There was a template for Kyverno exceptions and policy exceptions. Quickly, what's the difference? There's, in old versions of Kyverno, there was a config map for exceptions, but now there's a specific custom resource definition called Kyverno exceptions, so we still support both. That's why there's two of it. So we are gonna set the policy exception. Obviously, we provide a small guide to our developers about this, tell them how exception can be set, how it can be approved, and so on. So it just, you specify your application and you specify the name of the policy, which you can see here is this. And you get it in your report also. So let's get exception. I'm gonna do helm install upgrade again. For the, not for the chart, for the onboarding, because I'm doing onboarding. So here I have different folders, but in real life, when you're a developer, you usually collect all this in your own Helm chart folder. This is just for easily demonstrating the different parts. Helm upgrade install. Yeah, I install my onboarding chart again. Now this time it will create a policy exception for me. I'm checking my, quickly my policy exceptions, and they see my exception is created 13, 14 seconds ago, and they go here like, I still get errors, but there's an exception. So if I change this to the enforce mode, your application will still work because you have an exception in this case. So I hope our DNS name is ready. Quickly going to check this. It should be HTTP, I believe. Yeah. So we are also able to access to our service from the ALB DNS name. Yes, looking at my notes quickly. Cool. So, if we reflect back, we were able to create everything we need, cloud resources, namespace, via YAML files. And platform engineers has a way to control what they want in the cluster, what they don't want, by policy engines like Kyverno or OPA. This policy can be written for example, for crossplane also. Like if you are using crossplane and you don't want your developers to go crazy with instance classes and only allow them specific type of instance classes, you can write a policy for it. You can allow only specific instance class. If you want control the engine version, same. If you have another requirement in your production Kubernetes clusters, you can make a policy for it. So if we go back to our presentation quickly here, let me open it. So this infrastructure team, security team, Jira system, all this, we removed this from the picture. Now we are able to get into clusters in a self-service manner, deploy the services we need, and platform engineering or infrastructure or SRE team, whatever you name it, abstracted away all these complexities. They just gave you templates for the external secret, for crossplane, for onboarding, and that's it. Behind the scenes, everything happens in a magical way. So yeah, our demo showed a small Flask app. It connected to AWS RDS instance and self-service platform. So the solutions out there, or the solutions we are using, as I mentioned, we are not using crossplane, but the onboarding chart is exactly what we are using, that I showed you. Or we are using Kyverno policies in the exact way I showed you. We are using external secrets in the exact way I showed you. So you can take some of this, try it, adjust it, and continue from there. This is not only way of self-service Kubernetes platform, but what I showed is one of the ways. So, thank you very much for being here today. The slides are available there. Happy to get in touch, talk to you, answer questions. Thank you very much.
So thank you, Fagani. So we have a question. Have you ever thought about using Ansible to automate this further? Would this be a good use case for it?
Again, it depends. For example, in our use case, we don't really need Ansible because, for example, in this use case, or like if crossplane or if AWS controllers or if Terraform lets you to create everything, you don't really need to introduce a tool like Ansible. But if you have a specific need, yes, you can. We are mainly trying to use Kubernetes itself as an abstraction layer between our infrastructure, cloud infrastructure, and between developers. So we are trying to, make everything on top of Kubernetes if possible. But yeah, we don't need Ansible. That's why we don't use it. If you don't need something, please don't use it. But if you need it, yeah, if you have use case for it, you can use it.
Okay, thanks. Do we have any question from? Okay.
Hello, Roman Prokhachenko here. And first, it's great to see more companies getting on board with the platform engineering approach. So thank you for the presentation. So my comment to this is like, we've been trying at our company to run exactly that approach with common charts for roughly about 2 years. And then we stumbled upon the situation that you simplify these things. Developers just need to add a couple of bits and pieces to get the app running. But then with the time, the approach starts to scale, and there are more and more bits and pieces developers need to add, and then you try building another meta chart to combine. So have you considered maybe using some sort of service bootstrapping platform like Backstage.io, Ops Level, whatever?
Yeah, so actually it's not in this slide, but Harness.io is our main CI/CD platform, and this onboarding Helm chart, actually it's offered to our developers as a service in Harness. So like they are not really using it in a way I did here. I just showed it as an example. We have abstracted this away as a Harness service. So whenever our developers build their pipelines, they just drag and drop this service, put it in their pipeline, and they're on board. We control all the version upgrades. Whenever new versions available, we just update and it gets populated to all namespaces, all developer platforms. So we do it based on our CI/CD platform called Harness. If you have Backstage, if you have Jenkins, if you have something else, if you have GitHub Actions, feel free to do it. At the end, it's just, the logic is this Helm chart, but we further abstract it away with Harness.
Thank you.
Okay, we have a question on Slido. If you don't use crossplane in your company, how do you create AWS resources?
So yeah, we have an approach of a specific GitHub repository with Atlassian connected to it. So developers have Terraform templates. They get a PR request to this repository called Global Infrastructure, and they do Atlassian plan and Atlassian apply, and they get it. So currently it works in that way. We are actually, what I showed, again, it's a big learning process. We are considering crossplane, we are considering other alternatives, and there's no harm to switch to crossplane or others if needed. But we already have a different solution for this Terraform provisioning, and we just don't use crossplane. That's the only reason.
Okay, thanks. So do we have another question from here? Okay, so thank you.
Thank you very much for being here.